Continuing on with class number 5 in thermodynamics, here is an example out of the book. What is the mass of air contained in a room that is 6 by 10 by 4 meters if the pressure is 100 kilopascals and the temperature is 25 degrees Celsius? All right, well, so I don't always do this, but I should write down what the given is. So 6 by 4 by 10, I don't know why I reversed those, but I did, meters, right? And then pressure, it's going to be 100 kilopascals. Now, they didn't tell us whether it was gauge or absolute. In this section, it turns out, if you look at this problem, they did mean absolute right there, but we should be very clear, right? That was kind of naughty of them. Most of the time, I would tell you when given a pressure, and I gotta see if I did this in my homework or not. I'm gonna have to double check and see if I did. I gotta make sure I fixed that if I hadn't. I should give you and tell you, because most of the time, if someone just tells you a pressure, they mean gauge. Because most people just read things off gauges. And then see, the temperature is 25 degrees Celsius. The good idea is just quickly as possible go and add in 273 Kelvin to make this into a Kelvin so you won't forget. And then also note that it was air. So what we want to try to do is find from this the mass, right? So here you go. First we'll look up R, and we could do it either way, either with the moles, with this value, and then the moles molecular, or we could just go 0.287. 0.287. These are kilojoules per kilogram degree Kelvin. Did I get that right? Notably, we're going to multiply that by 1,000 because the kilo, 287 Newton meters per kilogram degree Kelvin. So sometimes I write out PV equals MRT instead of looking it up. And so we go M is going to be PV over RT. The pressure is 100 kilopascals, so that's 100,000 pascals, which are a Newton per meter squared. It's always good to go to base units. The volume, which we could have figured up above as being, let's write this up above. It's going to be 6 by, so what is that, 240? Yeah, it should be 240 meters cubed. So 240 meters cubed divided by 287 Newton meters per kilogram degree Kelvin. And then lastly, the Kelvin was 298. So let's do a little bit of slashing off units. Here's Newton and a Newton. There's a kilogram is what we want. There's a Kelvin and a Kelvin. Here's a meter squared divided by meters, and there's a cubic meters. There you go. It all works out, so we left off with a kilogram. We do the math, we get 280.6 kilograms. And we're only 4 minutes into this video. So maybe we should do the other one so we don't have just a bunch of small videos. No, there's two. There's two right here, so that's enough for one video. Okay, so this was a short video. I'll show you my ideal gas law setup. We're going to use here, not in the next video, maybe one in a couple minutes. All right, so let's take a look at the ideal gas law setup. And it's upside down. So let's turn it right side up. Here's our little ideal gas law, little thing right here. We're going to plot out the ideal gas law ourselves. got a little handle here. Compresses it. I saw this in a catalog and told Cy Yavistruk that, man, this is kind of a cool little deal. And next thing I knew, he like bought it. So that was kind of cool. So that's coming up soon in a video.